All right, ladies and gentlemen. So yesterday we talked about how to solve absolute values. Today we're going to do a quick video on what happens when there's stuff outside those absolute values. So yesterday we talked about the rules for doing it, the steps to do it. We took some notes on that. The first one was to isolate your absolute value, meaning you need to get the absolute value bars by itself. Everything inside the absolute value has to be the only thing on one side. And then we can split our absolute value into two sides and then solve those two equations. Okay, so everything we did yesterday, everything was already solved for us. We didn't have to isolate anything because the absolute values were isolated already. So now what's going to happen is a lot of our problems are going to, well, we want to isolate this. We need to get this thing right here by itself, this C, uh, this absolute value of C. That is my absolute value, which means this 2 has got to go. We don't like that 2. That's what's not isolating our absolute value right now. So we need to get that absolute value isolated, which means we need to get 2 out of there. Okay. And anytime we're trying to isolate our 2, you can almost think of this as like a big X. What if this just said X here, right? If this said X here, how would I get my X by itself? If it said X plus 2, how would I get the X by itself? Well, I would need to subtract 2, right, to get that out of there. So that's what we're going to do. We're going to subtract 2 and be left, hopefully, with our absolute value all the way isolated. So if I subtract 2 from both sides, remember, it's still an equation. We still have this dotted line, which means anything I do to the left side of my equation, I have to do to the right side of my equation. So this says that the absolute value of C is equal to 12 minus 2 is now 10. Okay, so we have that the absolute value of C is 10, which is great because now we have our absolute value bars isolated. We have it all by itself, which means we can take our two equations. This one's pretty simple from here, right? We can take this and we can separate it into two equations. One says that the inside of my absolute value of C is equal to the positive number, exactly what's over there, 10. And then we also need to say that C is equal to the opposite of that side, or negative 10. Boom. We're done here. And there wasn't a lot to do with that absolute value after, but this is how we would do one step to get that absolute value isolated. Okay, so we'll do a couple more of these and we'll talk about different ways you might have to get that absolute value isolated. So once again, we have that 6. That 6 right here is on the outside of my absolute value bars. So if it's on the outside of the absolute value bars, it has to go. We cannot have things on the outside of our absolute values when we are trying to solve these. They have to go. Anything on the outside has to go. So I'm going to get rid of this this 6 here, right? So if this said 6, let's say y, just to switch up the variable just so it's less confusing, is 24, what would we do? Well, if I just had an equation that said 6y equals 24, I would divide by 6, right? We know that this is multiplication. We've been doing this all week. And so I would divide by 6. That's the exact same thing I'm going to do here, okay? But I don't touch anything inside the absolute value. So similarly, I'm going to divide both sides by 6. Just like as if there was a variable there, these 6's will cancel out, and I'm just left with x. The absolute value of x is equal to 24. Oh, just kidding. 24 divided by 6 is 4. So the absolute value of x is 4. Wonderful. We'll still do the same thing, but once again, there's not a whole lot to do coming out of here. Either x equals a positive 4 or x equals a negative 4. We're switching these. But that's from yesterday. That part's not new. I'm just worried about us getting our x value isolated, so dividing that 6 on both sides. All right, and our next equation is a little bit more interesting. It's got a little bit more going on in it. So let's check that out. Okay, so similarly, this whole problem here has something outside my absolute value. We can't deal with stuff. We can't solve our absolute values until we get everything with everything that's outside of my absolute value out of there. Okay, so right now, this is my culprit. This is my problem. We can't do this until this 2 is gone. Okay? So I keep writing these off to the side. If this said 2y, so I'm saying like this whole thing was just a variable, right? If I took that whole thing, and let's call that a variable, equals negative 14. goes to negative 2y. I would divide by negative 2, right? So we're going to do the same operations as if that whole absolute value, we're treating that whole absolute value like it's a variable right now. Okay? So I'm going to divide both sides by negative 2. I'm going to divide both sides by negative 2. Remember, anything you're doing to one side, you're doing to both. And these will just cancel out. I have none of those 3's or those z's or anything inside my absolute value gets touched at all. Okay, so if those divide out, I get that the absolute value of z plus 3, the inside of my absolute value was not touched at all, is equal to negative 14 divided by negative 2 is a positive 7 now. Okay, so once again, when I divided that away, I did not touch anything inside my absolute value. We almost treat it like a variable in that kind of sense, right? So I don't touch anything inside my absolute value. And then finishing this one is a little more interesting, right? Because we need to take our insides, we need to take what's inside here, and we need to say, hey, what if the insides, z plus 3, plus was equal to 7. So just the normal one, exactly what was there, right? And then the other one says, well, what if z plus 3, what if that was equal to negative 7? Because that would also give us a solution, right? So we have to find both of those. So to find both of those, we will need to solve these equations now. And if we're going to solve something that says z plus 3, we're going to need to subtract 3, minus 3. Remember, these ones, you have to be a little careful. These don't have quite a similar answer. 7 minus 3 is 4. But if I subtract 3 over here, negative 7 minus 3 is negative 10. So remember, those numbers don't have to look the same. Just because most of our examples have kind of similar numbers as the answers, we would expect to see something like this, a positive 4 or negative 10, something like that. Okay. All right, I think we have one more example that I'll go through. And our last example here has 2 things. So this is about as complicated as I'll get. And honestly, even on a test, you might not see something quite this big. But we need to treat this once again like that whole absolute value. What if this whole absolute value was a variable? What if that whole absolute value was a variable? What if that was a y? I'm going to rewrite it just so we can talk about it quick, and then we'll actually see it solved. So if instead of that being an absolute value, what if this said 10y minus 3 is equal to negative 83? Well, we know what to do with that. We've been doing these two-step equations since last week. We know how to do two-step equations. If I were doing a two-step equation, I would be adding 3, right, and then dividing by negative 10 and then be done. Okay, so we're going to do the same thing, but we just need to do them with the absolute value here. And the absolute values don't get touched at all. We're not touching anything inside the absolute value when we're solving for them. So you won't get those involved at all. We're just trying to get rid of that 3 and then get rid of that negative 10. So it'll look something like this. We need to first, just like any other two-step equation, get rid of the 3. So I'm going to add 3 to both sides. If I do that, I'm left with negative 10 times the absolute value of h plus 5. Once again, I did not touch anything inside the absolute value. We don't touch stuff that's inside the absolute value. We need to first isolate it. That's what we're doing. Negative 83 plus 3 is negative 80. Great. And this one looks weird, right? Because it's all equal to a negative, but the nice part is if we divide by negative 10 right now, we divide by negative 10 on both sides. These cancel, and I'm left with the absolute value of h plus 5. And over here, negative 80 divided by negative 10 is positive 8. And that's why we can still do it. So it looked like we were going to get a negative number, but we have our absolute value equal to a positive, so we're in good shape. Okay. So once again, when you're doing your 2 steps or 1 step or whatever it is to isolate your absolute value, you're not touching anything inside the absolute value. I can't stress that enough. And another important piece, do not try and distribute that negative 10 into this equation. I should have talked about that last one too, but we cannot distribute into absolute values. They are not parentheses. They do not behave like parentheses. You may not distribute that 10 into there. Please do not do that. Okay, and then we're going to finish this off just like last time. Hey, this stuff in here, well, h plus 5 We drop the absolute values and keep that side the same. So h plus 5 equals 8, or h plus 5 is equal to negative 8. The opposite, right? Because either of those would work after you take the absolute value of them. Wonderful. So we'll finish this by subtracting 5 on both sides. 8 minus 5 means that h is equal to 3. Great. Or if I subtract 5 on both sides, then h is equal to negative, what, 13? Okay. So the moral of the story here, ladies and gentlemen, anytime that you have stuff outside your absolute value, you need to solve for that absolute value first. We need to isolate the absolute value, which means anything that's outside my absolute values, you need to get rid of. You need to get those out of there just like you would any normal equation. And if you're doing stuff to move that outside junk around, you don't touch the inside of your absolute values. Okay. Make sure you follow up with any questions and complete your assignment for the day. Thank you.